Hello, welcome back. A lot of drones flying in Avalon City today. Air quality is still good though. Last time I did a pretty cool reactor status display. Kinda using the counting properties of a 100p14 in a way they didn't need to be. Could have made it a 200p14, but they cost the same. But, you know, I made a contraption work and I'm happy with it. Blast from the past. Hey, Carl. Hey, how's life in Avalon City? You solve all of humanity's problems yet? Some of them! Things here at Longtung are mostly the same. That's probably not surprising. Wang Yonghong, who was apparently our CEO this whole time. Did you know that? Nope. Anyway, he retired. Never heard so much as a peep from him, so it's all the same as far as I can tell. Lily is the CEO now. Ah, of course she is. That makes sense. And she's doing a pretty bang-up job. Joe was promoted to her old spot, and he's doing pretty well too. That's a little more surprising, but good for him. David moved back to San Francisco with his wife. Last I heard, he's a consultant who tells American companies how to adapt their products for the Chinese market. I suppose we'll see how that goes. Jay's still the head of the engineering department. His daughter made a couple more games that everyone here got hooked on all over again, so it's probably a good thing she's off to college now. As for me, well, I'm alive. The company's grown quite a bit since you left, but they're hiring mostly homegrown engineers now. These days I'm just the gibbering pet Englishman in the corner, whilst the rest of the team go on with the business of making products, taking over the world, etc. No, that's what we're doing here, I think. Take care out there while you're doing your important work, and don't let Mr. Sun get you down. Ta, Carl. Okay, how much time is supposed to have passed here? It sounds like a lot. This sounds like years in the future. Because like a lot of stuff has happened. Interface. Cameron Farzan. Neuro. Ooh. And Pinsker. Elec. J. Thiel. Elec. Let's get a custom board going for the current design. Did you even introduce yourself, Cameron? I guess someone's too busy for introductions. Cameron is leading an effort to design a low-level brain-computer interface. It's part of the NETHUNS project. NETHUNS? NETHUNS? I don't know. Alright. So, brain-computer interfaces now. Fantastic. Sense 0 through Sense 5 are simple inputs connected to neuroactivity sensors. New music. Got something very constrictive here. Alright, so we're doing neuroscience. This is the neuroscience music. Output is an X-bus input connected to a computer for analysis. When pulses occur on 2 or more sense channels within a window of 2 time slices. Okay. Report the sense indices over output in increasing order. Do not report the same pulse more than once. What? So first of all, it makes it very, very clear that I'm supposed to do this. Other way around. There is some horrific traffic noise outside right now that I'm sure the microphone is picking up. Nothing I can do about it though. Do not report the same pulse more than once. Okay, so now hang on. Oh, this is actually mandatory given the narrowness of this channel. There is no way I could get enough simple pins in here to process those before I have to go through the squeeze. So I'm guessing this is going to end up being like this. So forced to process the DX300 version of these. Hold on, can I do better here? I believe I can. There we go. Alright, oh, isn't that nice? So, what am I doing? 015. 015. Okay. 025. Nothing, because that's only one pulse. Okay, this makes it a lot clearer than the description did. 0123. Oh, last 2 time units. Okay, right. So any 2? Does the window slide? Like these 2, then these 2, then these 2? Okay, so those... Okay, I get it. Don't report the same thing more than once. Well, but... Hold on. Do not report the same pulse more than once. Let me see if I can find a spot where a particular pattern occurs. At a glance, I don't see it. Alright, so first time unit. Do that. 025. Oh, so everything in the test data clearly has only a length 1 pulse. There's nothing that, there are no width 2s here. There's no analog input, it's just 0 or 100. If it's 100, it will be 0 the next tick. I'm going to build that assumption into my program. So I'm looking for a pattern that's like, say if there were a pulse here, if what it's talking about with uniquing the pulses is if I'm supposed to, oh, but the way this output is, since it's going to make sure these don't overlap. Okay, so 1, 2, 3, 4, 5, 6. Yeah, so odd number, or even odd depending on which way you count. Okay, so we get a 1. Well, okay, so let's look for another pattern. What if I get 3 single pulses in a row? Like, no, that's just 2. I won't get 3 single pulses in a row. Okay, so here's something interesting. No, those 2 are reported as 2 and 4. Okay, I'm starting to get something. So 6 of these. I need to write out some logic before I can really make anything happen. So what am I attempting to do? Let me get a clear idea of what I'm doing before I attempt to write out some code here. Got lots of space, huge amount of space here to expand into. But it does start with 2 3-digit numbers with 0s and 1s in them. So, tasks. That's non-trivial. So if I have two DX300 outputs, between those detecting when there's more than one 1 in the... Okay, I think I know more or less what I want to do. It's going to involve one of these. A picture is taking shape. I believe I desire to have you simply write the state of these out to this. So that'll store my one-time unit back buffer. Now, okay, so the order of this, by the way, how much does it matter? Well, I can reinterpret if I need to, but let's try and get it into order. So since 0 is here, x0... Yeah, p0, p1, t2. Okay, sure, so just move x0, x3, move x1, x3... might want to give a little ping to this to wake it up. Also... Now, hold on. I might be able to do some processing here with this huge instruction space that I have. If there's nothing I really want to do other than writing to this... Yeah, okay, so here's what I want to do. Yeah, okay. I think I can make this make sense. You will detect for the current time unit whether there's more than one bit active. Maybe. I'll attempt that at least and see how far I get. Let's try and do it for 1 first. You'll also write the state of that out here. No, that doesn't make any sense. Yes, it does. Yes, it does. Okay. I want to... Actually, then I don't need this for what I was going to do with it. Oh, but I do. But I do because I need to know which indexes are which. Okay. So what I'm coalescing on here is that I want you to read the state of these bits, write the raw state of them to this, just so I have the data around for later output when I'm ready to output. Then you will determine whether you're going to count how many bits are active and send that data on. Somebody will receive that information, and based on it, determine whether in the last 2 time units, 2 or more were active. If that's true, go back 1 time unit in this, so you'll have connections to that and that. And something here, so that means you'll have to move this way. Here, I can... Okay, no, hang on. This needs outside world access. Ooh, that's... I guess that will necessitate this. Well, this is just looking silly. Well, if I'm doing that, I might as well do this. Okay. So this will be your outside world pin. Maybe. Yeah, that's how it would have to be. Anyway, yeah, so if you... What I want to communicate from here to here is a count of bits. You'll store 2 back, so you'll do like a flip-flop, store in dat, move dat to ACK, store in dat, move dat to ACK, store in dat, something like that. Then, yeah, that should work okay. See if added together, I think I can do this non-destructively. See if when added together those add up to 2 or more. If they do, then you would also report the address of this. I guess. You don't have a connection to the address line. I can change that. No, I can't. Nope, I'm out of pins. Someone else will have to have it. Oh, well, yeah, so why am I doing this when I can instead do something much better? I can do that, and I don't know, this, and then that's your outside world pin. Sure. Yeah, okay, so same data and address lines. That's super fine. Okay. Yeah, okay, so this didn't go anywhere. I got my clearer idea as soon as I started writing it. So I'm gonna do some destructive things with this. How do I count bits? Is there a better way than... Okay, let's see here. If I'm operating on ACK, then I can't count with that. Okay, how do I count bits? I guess here's what I can do. Okay, I get it. Got an idea, at least. Well, I can do that once for one of these, and then that'll send a 0 or a 1. You can just add 6 times and get a sum of how many of those are there. Plausible. Doesn't fit in the instruction space for both of these. Could I... Yeah, okay. So how about a decomposition helper? So a function call that I would do... Okay, yeah, so let's reroute this a bit. For now, I'm going to do that. I probably won't like that eventually, but right now that's what's going to happen. I want to occupy this space, because you don't need all those pins. You're going to need to be a little bigger. Because you need access to... I shouldn't have deleted all that because I actually want that code back. It wasn't much, but it's what I want here. I can't redo. Alright, that's fine. I did basically nothing. I did this. Not x2. What am I doing? x0. It's your x2. Move x0 dat. Yeah, sure. Here. Okay, so this waits to be past a 3-digit number. It's going to decompose that number and send back each individual digit. You're going to add those together. In your ACK register, sure. Let me just make it very clear how I'm operating on that. Okay, so that's 1, 2, 3, 4, 5, 6. This might fit. Okay, sure. It won't. Fantastic. Wait, yes it will. I'm counting both at once. Okay, so I save a move 0, ACK. Okay, so I move dat, x3. Sure, so I'll output the, might be able to get away with, it would feel good for layout if I could do this, and maybe this, but I doubt I'll be able to. For now, let's just not even think in those terms. So yeah, first number needs to come out of there. Oops, second number needs to do similar things. ACK stays the same because I'm counting both at the same time. Move dat x2, add x2, add x2, add x2, move dat x3, move ACK x3. Shoot, I need to sleep. Aha. Okay, that's not so unreasonable. Okay, so here's what I can do. You can expect 2 values. No, you can't. No, because you're reporting after every single... How can I make this work? I just need a sleep command in here and this will fit. x0 dat, dat x2, 0 to ACK. See, this has to be repeated to 2 different places. Ah, here's what I can do. I can have you be the repeater. So move x0 to x2, move x0, x1. Whoa. Yeah, move x0 to x2. That's correct. Move x1 to x2. Don't bother doing this. Don't bother doing this. Okay, I feel like for some reason I want this to be x1 and I want to wire it like this. That just feels like the thing to do here. So on x0 you're going to receive some stuff. 2 values that you will write out to... okay, somewhere. I'm gonna need more I/O expansion. No, you can write the values. Oh, check it. Here we go. That's nice. That's actually perfect. There we go. That works. And you only need just the one data line to this. So that moves to x3. Great. That works fine. So your SLX on x1 now. Okay, yeah. So what I've done... I forward this message to you. You'll do what you need to do with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How annoying. Oh, but I still also need sleep 1. All right, 11. Whoa. I said 11, so I typed 11. All right, forward the message to you. You'll store it and then decompose it and send back the decomposed results here. You add those together and feed it a second value from this one. That writes it to there. And... right, okay, so I'm going to want you to have access to this stuff. And I guess X0 is your outside world communication line. Sure, that's maybe fine. We'll see. Okay. That does seem okay to me so far. Alright, anyway, so you feed that... Here, let's make this just a little clearer. In fact, let's make this a little more clearer. There we go, because it will start at 0. Alright. Forward the information. It gets written to here, gets decomposed, sent back here. The decomposed results get added together, both sides at once, so I'll get a number from 0 to 6 in my ACK register. I send that number on to X3, and that's what this is going to act on. Then I reset to 0 and sleep, and you're ready for your next tick. Yeah, so you'll get 2 messages in the same tick for this, and then sleep for the rest of it. Great. Okay, so this is working all right so far. When you receive a message from this... oh, I can do better! There we go. So you won't even wake up if there are not 2 things in the last 2 time units. No. I guess I can do this. No. This needs to be every time because this is only for 1 time unit. You have to keep track of last 2. I'm gonna have to decompose again. I think. Oh dear, yeah, okay, so for the output step, I'm gonna do something similar to this again. I might need more access to you. That's fine. I can actually just run this through here. Okay, I guess not. Okay, well, that might be a slight problem. Well, cross that bridge and I get there. Okay, so you're only reporting bit count for a single time unit. But that is a useful first step. There we go. Okay, so I don't destroy my data that way. Hold on, but I don't destroy my data in any case. Or rather, I only need to remember 1 back, and the data is uncorrupted. Okay, so... alright, so when I receive a message, a tick has gone by. I move the old pulse count from the last tick from dat to ac. I move the new one into dat. Then I can destroy the old one because this is the last time I care about it. So I add dat to ac. This makes sense so far. And I test if there's more than 2. No, if I test this is more than 1. So if multiple senses are going at the same time, that is when I need to report. So when this happens, it's necessary to communicate to you. Oh, okay, yeah, so I really want to call this function again. Someone else is going to have to do it, though, because I'm out of I/O space, right? No, not necessarily. Now, hold on. Yeah, I'm out of I/O space. Or, like, I need to talk to somebody else for... I need this to happen. So yeah, I need that to happen. That's fine. I'll do something else here. So when this happens, I need... to communicate to someone. Hold on, before I do this, let's just pretend that I can read from x2 the last 2 values that were written here. That won't actually be true, but let's pretend. I'll have to do some extra stuff for that to be true. Okay, so TGT-AC1. I don't need to... I do need to branch past here. No, I don't think I do. Okay, so TGT-AC1 plus move x2, x0. So I call this function again. That goes in here. x0 is going to send me back. You're already sleeping at this point, so you won't be listening on your x2. Move x0, x3, I guess. So you're reporting to someone else. Okay, well, actually, maybe I can do better. No, not really. So you're calling the function, you're forwarding the information to someone else. That is a valuable thing to do. I guess I can do this. Well, I need this. No, I need more of them. I need 4. Okay, this needs to happen a few times. Got it. Okay, that's reasonable. All right. Wait, that's no good. Okay, there's an interesting complication. I need to merge 2 pairs of samples. So I get a pair of samples per tick because I have 6 numbers. I need to basically go back 4 here. Decompose 1, 2, 3, 4. It doesn't feel great that I'm doing this decomposition twice. Could I store the results of the decomposition here instead of... instead of the raw values. How much data is that? That's 12. I think I could. Okay. Okay, let's do that instead, just so I only have to decompose once. Also, I note you're not using your X1, so I can actually... Well... Yeah, I can move this over here, and I guess that compacts this, but it doesn't help for this connection. That's fine. I'm gonna need access to A0 though, so that still has to stay over there. That's fine. Okay, so what am I doing? Instead of moving X0 to, or instead of moving dat to X3, I actually move AC to X3. So I write the 1 or 0 for that. Okay, yeah, I see how this is gonna work. So steps are basically take raw things, turn them into numbers. That happens at the X300 level. Count the bits for 1 tick after 1 decomposition. Send that over here. Add that count to the previous tick's count and see if the two together are more than, or 2 or more. If they are, then while this was being decomposed... Oh, no, that's fine, that's fine. If I'll only ever call this once per thingy. Right, so I'm not recalling the decomposer. Okay, yeah, so this stores the broken out bits of this. So every tick, this will write 6 values here. Since I only need to go back 2 ticks, that's 12 at maximum, so it will fit in here just fine. Okay, so right. We're just writing 0s and 1s, that's all. Binary. X0 dat, move dat ac, DGT 0, move ac x0, move ac x3. Then do it a couple of more times. This will just barely fit. Sweet. Good stuff. Okay, so you do report back because I need to count bits. So yeah. You direct input and count bits and report counts. You decompose, report decomposed values to 2 different places at once. The second place is this, which stores them, which you will later read. Okay, so a future step then is to combine values. So basically, like, I would add address 0 and address 6. 6 is here. Address 1 and address 7. Address 2 and address 8. For any of those that are over 0, I report that index to output on ticks when I'm outputting. Perfect. Okay. Well, hey, that's a... I think that is a perfectly phrased way to handle this problem that handles all the cases. Now I just have to write it. So where did you land? You wait for your count. Yeah, okay, so you're doing the bookkeeping of, like, what was the bit count last tick and what was this tick. That all works great. What I don't have is anything beyond this point. Okay, so from here. The interesting stuff. When I know I need to output... Okay, so I gotta back this up by 12? Ooh, I got a better way to back up by 12 than by reading this, doing arithmetic, and writing back to it. Just read data twice. Sounds great. That's much better. That's more efficient in every way. Alright, so plus 2 in a ring buffer of 14 is the same as minus 12. Great. Having done that, you're not going to have anywhere near enough instructions to do the rest of this, are you? Maybe? Now here's the thing. What about the whole alternating between... Ah, okay, so let's have 2 addresses at once. Hold on. Now maybe I do want to do arithmetic. If I'm doing it this way... Okay, yeah, so for... Yeah, okay, I know what I want to do. Just not exactly how I'm going to do it. Okay, so who can have enough I/O pins? Nobody. Okay, you're going to set preconditions. Yes, you're going to set preconditions and then forward on to someone who can actually read the data lines and do something productive with them. That's going to have to be a little different from that. Okay, this wiring's a bit awkward. Would it work any better like this? Heck no! Not even slightly. So yeah, idea is you would set A0 and A1 appropriately. A1's only touched by the output thing, so basically I back A0 up by 6. Oh, okay, cool. Then I only have to do arithmetic on that. I move A's. Okay, great. So move X2. Yeah, sure, that's fine. X2, X3. Move X2. Okay, sure, yeah, move X2 also to AC. Yeah, at this point, you don't care what the bit count was for anything. You just know you're reporting. However many bits are set, that's going to come out in this process in the future. Great. Ooh, here's a way to make my pins better. There we go. So you'll actually talk to X2 instead of X3. Since you don't use your X3, I can just wire right through it for connection to that there, which allows more efficient routing to this, and everything gets a lot more comfortable. Sweet. In fact, why don't I change this around a little bit, just so I don't have to do this wire. Wait, hold on, who went where? Okay, so your X0 is A0. Your X2 is going to be A1. You don't access D1, but someone you talk to will. Okay, something like that. Yeah, okay, so that's as well as I'm going to get that to work. Great. So this means move X0 to X3, move X0 AC sub 6, move AC X0. Okay, great. So your preconditions are set, and then you can just send literally anything at all onto X3. Oh. Okay, great. You're done. So now you listen. Yeah, see, with this simple pin is why I didn't want this shape of thing. Hold on. Didn't you need a connection to D0? Yes, you did. Okay, so that's what makes this complicated. Okay, right. D0 needs to escape. Right. That's interesting. D0 and D1 are what move on to there. Maybe I can... If I can move this up one, it'd be nicer. Well, I had it up one before. Well, alright. So I'm at the part of my puzzle where I take a break from code and I do some physical space management. Yeah, I don't like this. So let's put this on the board just so I know where it's going. You need connections to D0. And, okay, right, so I can't put this here because I need access to A0. I can put it here and get access to A0, leaving all my ports as they are. But this D0 needs to continue, and that feels really awkward for getting access to A1 and D1. Maybe it's not. Maybe I can make it work nice. What if I did this? It's not great, but you know what? It's probably good enough. So I don't know, your output goes there or something, and I don't know, your D1 goes there or something, and your X0 talks to this X3, and this X0 talks to A0, right? Sounds okay? I think the pins even landed in the same place. Nope, not quite. X2 is now the A1. Oh, and, okay, so I had this muddled a little bit. This expected X3 to be that. Okay, so, somehow it just feels better to do this. Just to make it super clear that's the same data. And that's what I'm doing to it. So I read A0. I write that value to A1. Oh, that's not right. That is not right at all. Oh, okay. So it's actually a little different from that. Move X0 ACK, sub 6. Move ACK X2, sub 6. Or X0, sub 6, move ACK X2. No, this won't corrupt my data because I will be reading 6 times from D0, therefore repositioning that offset that I did to A0 so that you can continue and not corrupt your data. Which I think doesn't technically matter because 2 of these won't happen in sequence, but it will indeed fix itself still. Yeah, because I didn't want A1 6 ahead of A0, I wanted it 6 behind A0, that's why I have to sub twice. And that is completely fine. Alright. Yeah, then I just tell X3, hey, you need to do something now. No, I might be able to use that value for something. This would feel tidier, or at least more centered, if I moved it this way a bit. There. So what's your job exactly? Okay, so it's complicated. It is complicated. Once again, I have a situation where I really want to operate on ACK, but also count at the same time. Maybe I can just do that. Maybe I can, like, actually use dat for that. No, I can do better. Here's what I can do. Shoot, no, I still have to count. I definitely do have to count because my counter needs to be output to output. Okay, so. Tech. No, GT D0, which is X1. X1 0 minus oh wait, hold on. No, I really do need to add these together. I can't do 2 separate tests to see if they're above 0. I can't do... There is no OR instruction in this language. Is there? Yeah, there is. Yeah, there is. This works fine. Right. If there was a pulse on that, then I don't even have to look at the other sample. I hope I'm keeping this straight in my head. Everybody else is probably lost. Don't worry about it. I'll try and re-summarize when I get through this. I think I'm semi-close to done. Every time I've said this, I'll be in video editing, I'll hear myself say it, I look to the right, and I have another half hour of video ahead of me. It always happens that way. Maybe this will be the time it doesn't. TDT X1 0. Okay, so minus move X2 null plus TGT X2 0. Yes, there we go. I believe that makes sense. So then plus move ac x3. There we go. Add 1. Tech ac6. It feels better to do tdt ac5. Minus jump loop. Move 0 ac. There's no way this is a complete program. Something's wrong with this. Right? Maybe not. Oh, check it out here. I can save a line. Okay, so hang on. So ac starts at 0, counts to 5. So from 0 to 5, I read from D0 and see if it's more than 0. I also either discard D1 or read from it and see if it's more than 0. If either one of those is more than 0... shoot, that's the problem here. This is an and, not an or. Yeah, that's the problem. So if this is... Okay, so now... I just have these the wrong way around, right? Okay, so... so this is how you phrase an and conditional in this language. This is how you phrase an or conditional in this language, right? So a minus on the second one for or, a plus on the second one for and. Yes, that is correct. Because if the first comparison succeeds, in the and case, you must do the second and fail unless the second succeeds. If the first comparison succeeds, if you're doing an or, you must not evaluate the second one and go straight to the success case. Yes, okay, so this is how you do an or. So first test fails, second test goes off and does this. What I need here is this. Yes, because I have to discard before I do the second comparison. Otherwise, this thing would activate the plus instructions and discard an extra value if these are in the other order as how they are. Okay, great. So I learned the difference between and or with this weird conditional system. I won't remember it, but I'll be able to rederive it when I need it again, because it's not too complicated. Okay, so then, if my or conditional goes off... so that's an inclusive or. What about exclusive or? I don't know. There's a piece of hardware for that. Anyway, then I output. I output that index, what I've counted to here. And then I just add 1. Okay, so other than reversing my conditional to be or instead of and, I think I've convinced myself this program's complete. It worked. It fails. Oh, I gotta clear everything out. I need a flush command after this. Okay, I can do that. Here's a way. Here's a better way. If you've output... Forget that last thing. There we go. That way I don't have to mess with these values at all. You just forget... Yeah, of course. Because you would remember... So yeah, what happened there was it detected 3 pulses at the very beginning. I should step through this slowly, maybe just to make sure it's doing what I think it is. Then it saved this in the previous tick storage area and added the next tick's pulse count, which was 0. So that's what this is talking about with reporting the same pulse more than once. So in the last 2 ticks on this tick, yes, there were more than 2, but you've already reported them. So I just clear my bit count for the tick that reported, so that this will be treated as 0 for the purpose of going forward, but then it'll just cycle through for the rest. Okay, great. Let's step through this and make sure it's doing what I think it is. I think it is. I mean, it seemed to work. Like, it was happy in the first tick. It had a problem that I could easily explain for the second one. But let's... Okay, so, yeah. Let's examine. So right, first thing that happens is decomposition. $11? 0, 1, 2. Shouldn't you be 110? Should you not be 110? How are you 11? Oh yeah, of course, right to left. The 1-bit is set, the 10-bit is set, the 100 is not. Okay, why was I thinking left to right? Of course, right to left. Okay. So yeah, copy this value to ACK, corrupt it with the DGT, send the corrupted value over here. That's the wrong word, but you know. So first bit decomposed, and also write it there. Okay, so get a fresh copy, decompose second bit, write it to both of these places. You're adding it together, so there are 2 bits set so far. This time you, right, so get a fresh copy, check the third digit, it's 0, send it to here, so we add 0, we keep 2, we add 0, this moves, looks great. We're going to do it again with the other value. So this is 1, 0, 0, so this will be 1, this will be 0, this will be 0, this will go up to 3. Oh. You got a 0. Okay, no. Right to left, once again. This will be 0, 0, then 1 to get here. Yeah, so this should look like this, of course. Okay, so there's my 1. I did that. This woke this up at some point that I kind of missed. That's like 6-1, move dat ACK. Right, so that copied a 0 over a 0. Move x1 dat. Okay, so this is the freshest value. Then I add it to the not-so-fresh value. I check if that's greater than 2. It is, of course. Your job is done. Your job is done. This is a pretty elegant solution. I'm happy with it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Check it out. You don't use your dat. You got 9 instructions. You're 4000x now. I'll redirect those a little bit. And there we go. I saved some costs. Okay. So get back to where we were. So here's 3. All right. I add those together. I do indeed get right. And in the process, destroying my old not fresh value, and I don't need it anymore. At the very least, I know this works for the first tick. I've already tested that. Move x0 ACK. Peeking at this and wondering if I could do it better. I think the answer is no. 1, 2, 3, 4, 5, 6, 7, 8. I've already counted this. It's 11. I knew that. Don't worry about it. It's fine. Move x0 ACK. Okay, so that's A0. So sub 6. So you're going to get 0. Set that to 0. Sub 6, you're going to get -6. Set that to -6, which ends up being whatever that is, 8. So you've set the preconditions on the 100p14, a pattern I'm now very familiar with, and then you tell this to do something, and then after you've done that, you reset your remembered bit count for this tick so that you won't re-report. Okay, so this line fixes the one bug I had. All right, so you get a 0 and just put it in there, and that's how you reset that. You do the test on... Why are you in the wrong place? You're not. No, you're reading the old values here, which didn't exist. You're going back in time into the past before you were born, and reading stuff here. No, this is the right place. And it doesn't matter which way around these are, because I'm just testing both. Yeah, it literally doesn't matter which pointer I subtract. Well, it does a little bit. It doesn't matter to you, it does matter to the rest of the program. Anyway, it's the right way around. Anyway, so TGT x1, 0. It was indeed. So read from this just so the pointer goes to the right place. And then we got a hit on 0, so 0 goes to output. Yep. So count up to 1. Check if you're done counting. You're not, so go to loop. Yeah, great. Okay, so this all makes perfect sense. Yeah, we got a hit on 1. We're going to get a miss on 2. So TGT X1, 0, false. TGT X2, 0, false. Didn't get a hit, so we just add 1 and keep looping. Cool. So it finishes this out. We're going to get a hit on 5. We got the hit. Okay, discarded the value. This pointer landed here. That's the important one. This one doesn't matter. It's only used for this. Great. Hit on 5. 5 is done. You are greater than 5 now. So you go back here, and this is going to get reset when you send your value there. Sweet! Perfect. Okay. Now that was a satisfying implementation. All right. Reading the brain. Kinda straightforward once you break it down into simple chunks. Cool. Alright, beat the average power usage. Lines of code's a little high, not too surprising. I have some unrolled loops here. I mean, this averages out to hitting the high peaks, so I'm perfectly happy with that. Great. Cool. Good stuff. Does this get you what you need for now? Yes. Cameron here. Man, a few words. Oh boy, okay, so we're gonna see the results of this this project here, huh? Oh dear. Do I really want to get involved with this? Okay, great. Well, hey, I'm perfectly satisfied with that. That was just a normal, good, cool puzzle. Alright, well, I'll see you next time for Scaffold Printer.